Hello everyone, my name is Vishwanath Adiraju. My research topic is on load balancing. Typically, load balancing is a method to distributing load across various resources within computing network. This activity of load balancing can be achieved between various computing resources like servers, clusters, websites, storage, applications, and etc. At our organizations, I had a first hand experience where we were facing latency issues when the load on our customer facing websites went up on every public holiday of the year. I'm hoping my research would help me learn more on this topic to come up with a permanent solution for our application. On the second slide, I have this table of contents which goes through the flow of my slides. So we'll first talk about the introduction, which tells about what load balancing is and why is this solution important. And we will, on the next slide, we will learn about the load balancers, types of load balancers, and also load balancing techniques that are available in the market today. And we talk about the final solutions that I have arrived from the research, followed by conclusion and the various references. So introduction. So as many of you are familiar, like you must have faced accessing a website or when making a purchase or a transaction. Mostly, I can relate to like the time during the times of Black Friday when you have everybody trying to storm in online and trying to make a purchase. You would see your website behaving slowly. Such situation has been experienced in our organization as well, and that is the solution we are trying to find on how we can, what is the best way to resolve this. So effectively, what do we know about load balancing? So load balancing is a distribution of the workload dynamically and uniformly across all the available nodes in the cloud. So this particular load balancing can be so I have pointed out this definition of load balancing from my resources of 5 and 15. And effectively this particular load balancing refers to distribution of incoming traffic across a group of backend servers that is expected to be distributed efficiently between the nodes or the server farm or the server pool or the nodes in a cloud. So this particular topic that I am researching is again on the website load balancing, where the servers could be load balanced as well. So this load balancing, the typical goals of load balancing include to maintain the load equally on each of the nodes and to make sure that neither of the nodes is actually being idle and to efficiently use the resources at any given point in time. So the output we will expect is to have a maximum efficiency of resource utilization and a good experience to the customer. So about load balancers, we have three different types of load balancers, what you can have on premise, or you can have it hosted in your data center, or you can have it hosted in a public cloud. So the public cloud can have again different types of load balancers which are hardware based or software based. So hardware based are only typically routing the traffic only between the servers and behind the load balancer. Whereas the software load balancer gives us more control, that gives us modifying the various logics that we could use in distributing the load across the servers. Types of load balancers. As we can see that load balancing can be done between various computing resources. So we can have application load balancers, we can have network load balancers, and also the classic load balancers. So an application load balancer typically makes routing decisions at the application layer, which is the HTTP or HTTPS that supports path-based routing. So in this, the route requests come in from the outgoing ports, and when they come in, the application load balancer will support dynamic hosting and port mapping. So next one is the network load balancer. A network load balancer makes routing decisions at the transport layer itself. So it can handle millions of requests per second, and after the load balancer receives a connection, it selects a target from the target group for the default rule using a flow hash routing algorithm. While the classic load balancer can do both application or network load balancing. So this is a combination. So depending on the use that it is being put to, a user can typically modify a classic load balancer to behave like an application load balancer or like a network load balancer. Next slide. Load balancing techniques. So when a load balancer is implemented, the user will have a choice on how he could implement it. So there are multiple ways it could be handled. There is static techniques available, and there are dynamic techniques. In static techniques, independent of the current load, the configuration would be made to distribute load according to based on a configuration file. So this particular static setting doesn't take into account of the current load that is available on a server. So this static technique may not be always useful or relevant in the modern days, as it depends on the kind of system your system that you're putting it to use to. So static technique again, it doesn't take into the system of current taken doesn't take into account of the resources that are being utilized on the current system. And in dynamic techniques, it is a very resource. It maximizes our resource utilization. It gives flexibility to the end user, where it constantly monitors the end servers that are behind the node. It monitors its resources effectively and makes a decision for routing the traffic. And there are several algorithms available to set our load balancer. The most popular ones include the round robin technique, where the data is distributed one at a time to each of the servers. And then the other one is weighted distribution. We have sticky sessions, min-min session, min-min, and min-max, and open flow. So in sticky sessions, we have a hash-based algorithm that makes a hash of the incoming client request IP, and then whenever the same request comes from the same IP, the request is sent back to the same server that was handling the previous request. In this way, they try to maximize the efficiency of the transaction that is in progress. Typically, like in a customer cart, when you go to an Amazon.com and try to add a cart, this request actually, the transaction will have a separate database of its own, where these particular cart, when you refresh the browser, it still will be available, because at any given point in time, that your request can go to any n number of the servers that are behind the cloud. So these sticky sessions allow you to complete your transaction without any issue. And then there are min-min and min-max, which are not these are the early methods that have been found that improve the open flow and as well as the load balancing techniques available. So the solution that we have arrived from the research is to make a combination of, it's a combination implementation, which is a hybrid solution that will allow scaling of vertically and horizontally of the servers of the websites. So this is again indicated in our research papers 17 and 19. So according to this solution, what we plan to do is to maximize or add all the resources that we want on each of the nodes that are behind the load balancer, and at the same time add all these nodes so that add these nodes behind the load balancer so that they can be distributed across the nodes. So for horizontal scalability, we will be, since we have a common load balancer, it allows us for horizontal scalability, and the application modification will also have to be done because our current application doesn't support a common database and a common application. So typically for all these transactions that are stored, that are performed by the website, are stored in a database, and when we are doing a horizontal scaling, it is imperative that your application supports the horizontal scaling as well. So in our case, we will have to make application modifications so that we can tailor our application to support this hybrid solution that we are intending to go with. So the expected benefits out of this solution is to see that our application is highly available architecture, and it allows highly, excuse me for that, it allows for high allows for scalability, and it allows easy maintenance of the servers because you have multiple nodes behind the server, so you could take down any one of the nodes for maintenance when needed, or if certain hard drive that goes bad and if you need to swap, you could do that. In addition to the RAID features that you could have at the hardware level, even you can completely take down a server since you have a load balancer, and that will handle the load while one of the server is being undergoing maintenance. So, and it also, this particular architecture is expected to improve better resource utilization by providing maximizing the application performance and adding customer satisfaction. And again, this has been a good research experience for me, and I'm adding the references here. I'll just give it a few seconds so that you can take a look at it. This is the first set of 6. This is the continued references. This is the last slide. And thanks again for listening into my presentation. If you do have any questions, do email back or if you further want to discuss or have another opinion on how to better implement this website load balancing, you can reach out to me. Thank you.